Welcome back. Today's lesson is going to be on area and perimeter. Let's look at some basic definitions. The perimeter is the sum of the lengths of the sides. So when we add up each individual side, we get the perimeter. Like the outside of a yard, the fence would be around the perimeter. The area is the number of square units that fit inside a figure. So if the fence is our perimeter, it would be the grassy area that we would call our area. A composite figure is just a figure that's made up of two or more geometric figures. So this arrow is an example of a composite figure because it's a rectangle and a triangle. And the last one we may be a little less familiar with, it's a postulate. And a postulate is an accepted statement of fact. And we're going to look at a lot of different postulates throughout our course this year. Our formula is the most important part. A rectangle, the area is length times width, and perimeter is twice the length plus twice the width. Triangle area is half base times height. Remember, base and height always hit at a 90-degree angle. Perimeter is just the sum of the sides. We can call them A, B, and C. Parallelogram is very similar to a rectangle, but its area is base times height, and it's that same concept where base and height have to hit at a 90-degree angle. Perimeter is still 2 times length plus 2 times width, so adding up the outsides. And lastly, the circle, the area is pi r squared, or pi times the radius squared. And circumference, which is the fancy word for perimeter of a circle, is 2 times pi times the radius. Or sometimes we've seen it as pi times diameter, because we know the relationship is diameter is twice the length of the radius. And our first postulate this year is going to be the area addition postulate. And this just says that if the area of a region is the sum of the areas of its non-overlapping parts. So for example, this arrow we talked about as a composite figure, we can find the area by breaking it into two smaller pieces, a rectangle and a triangle, and then adding those together. And this is something, again, pretty common that we've done before, but now you have the geometric reasoning behind it. So let's look at a couple examples. We're going to find the area and perimeter of the following figures. First, we have a rectangle. Notice that the length and width are 3 and 7. And so when we put that into our area formula, we get area of 21 centimeters squared. And then perimeter, we have 2 times 3 plus 2 times 7. Well, 2 times 3 is 6, 2 times 7 is 14, and we add those together, it's 20 centimeters. Notice on these that we have units. Area is always units squared, where perimeter is just units. Triangle. Base here is 5 and height is 6. Remember, we're always looking for that 90-degree angle. No matter how we flip this triangle, 6 and 5 are going to be our base and height because they hit at a right angle. So area is half of 5 times 6. And there's a lot of different ways we can evaluate, but 6 times 5 is 30, and divided by 2 is going to give us 15 yards squared. We can do it in that order because we've learned those properties of numbers, and the commutative property allows me to multiply in different orders. Perimeter is 7 plus 7 plus 5, the outsides of a triangle added together, which is 19 yards. And lastly, we have this composite figure where we're only looking for the area of that outside, that light blue area. So what we want to do is we want to find the area of the big square and then subtract the area of the little square. So the area of the big square is 20 times 14. And the area of the little square is 16 times 10. So we get 280 minus 160, or 120 meters squared. Perimeter, we're going to add the perimeter of the big square plus the perimeter of the little square. So we get both the inside and the outside of our shape. And you can see that we end up with 120 meters. If you have confusion, please bring these questions in, as we are going to be using this for a project we're going to be starting when you guys come to class. Lastly, circles. So we're looking for area and circumference. Area is pi times 9 squared, and it's 9 because it's half of the diameter, and half of 18 is 9. So we get 81 pi, which is an acceptable answer. Or if we'd like to approximate it, it's about 254 and 34 hundredths millimeters squared. Circumference is pi times the diameter, or twice the radius, which is 18 pi, or approximately 56 and 52 millimeters. Last example, we're given the radius. So we're going to square it and get 25 pi with an area of 78.5 feet squared. And circumference is pi times diameter, or 10 pi, which is approximately 31.4 feet. I apologize for the incorrect answer on the slide. If you have any questions, please let me know, and congratulations on making it to the end. We're going to start a project when you come to class, so make sure you have your formulas with you. Have a good night.